Hi SM and Assalamualaikum. I'm from Group 3. We present to you about our group assignment video.
So in our video, we will present the manual calculation, simulation of circuit, comparison between two methods and discussion of the results.
Hello everyone, my name is NADIAH binti MUSTAPA. So based on the figure 1, we use Shockley equation to find the IV characteristic. Shockley equation is ID equal to IV e power of VD over NVT minus 1. VT is equal to KT over Q. K is Boltzmann equation, T is absolute temperature and Q is elementary charge. So for this question, we use IS is equal to 20 nanoampere, N is equal to 2 and VT is equal to 26 millivolt. We use N is equal to 2 because based on this figure, we use a standard N1N4001 diode which is equal to silicon diode. So we do the table and then we can find the value of ID based on the Shockley equation. Then after done with the table, we straight to plot the graph for the IV characteristics. So this is how the IV characteristic graph looks like. Next, for question 2, we need to determine the operation point of the diode which is IDQ and VDQ based on figure 2 using the graphical or load line method. Here, we use the same method as the question 1 to find the IV characteristic first, which is use the Shockley equation ID is equal to IS times with E power of VD over NVT minus 1. We do all the table and then we plot the graph of the Shockley equation. So here is the graph of the IV characteristic that we obtain based on the table and the Shockley equation. Then to find the value of IDQ and VDQ, when VD is equal to 0, this part will act as a normal wire because it will become short circuit. So we use current divider to find the value of ID. Firstly, we parallel R2 with R3, then we can get the value of 0.05 kilo ohm. Then IT is equal to 36.4 milliampere and we get ID is equal to 18.2 milliampere using current divider.
Hi, I'm ISKANDAR bin MAIZUNIR. So I already designed a simulation circuits for question 1 and question 2. We can conclude that the value that we obtain is exactly same with the manual calculation one. And for the question 2, we actually use a Thevenin method and KVL method to obtain the IV and ID value.
Hi, my name is NURUL and BINTI HAKIME. After the values of VD and ID was obtained by using a Shockley equation, we plot a graph to get a curve of diode characteristic. Next, to confirm the exact values of VD and ID, we put the VD and ID values in the simulation circuits. By this, we obtain a specific and accurate simulation graph by putting the given values of VD and ID. For the questions 2, we also obtain an accurate graph in simulation circuit. By referring to the given questions, we apply the KVL equations and the Thevenin methods for VD and ID. Thus, we obtain the operation points of the diode using the graphical analysis or the load line methods. To check any dissimilarities values between the manual calculations and the simulation graph, values of VD and ID from the manual calculations was put into the simulations in the MAIZUNIR apps, and the result obtained will be compared with the calculation.
Hi, my name is NADHIRAH binti SHAMSUL. Next, we use the KVL method to draw the load line. The intersection between load line and the graph is the Q point, which is 0.7 volt and 6.35 milliampere. So this is the simulation that we get from the multism for question 1. For question 2, we use the same method to draw the graph, but then we use Thevenin method to draw the load line. Then we get the intersection of load line and the graph, which is the Q point, is 0.7 volt and 40.6 milliampere. Analysis of diodes is the topic of our assignment, and we use multism to stimulate the circuit for both questions. After we reviewed the question, we concluded that each question needs us to use the Shockley's equation in order to draw the graph.
So for the content report, for the introduction content, we already conclude the introduction of diode, problem background, problem statement, and assignment objective. For the methodology content, as we mentioned before, we create a simulation circuit to obtain the accurate value. And for the discussion content in this report, we conclude the diode application in biomedical engineering. For your information, diodes can play a vital role in photobiomodulation therapy, where replace the laser with LED. For the conclusion content, the reflection that we can make was we can deep understand about the diode behavior. So that's all from our group. Thank you.